Hey future chemists, this is Jessica and Yusuke, and we are going to go over a titration problem today. This problem can be found in the titration unit, example number 3. A buffered solution contains 0.25 molar NH3 and 0.40 molar NH4Cl. In part A, you have to calculate the pH of the solution. In part B, calculate the pH when 0.10 moles of gaseous HCl is added to 1.0 liters of the buffered solution. We will be solving for pH via titration. This problem will test your titration problem-solving skills. Vocabulary you need to know is titration, which is the process used in order to find the pH of a solution by adding a strong acid or base, depending on your solution. In order to solve this problem, you must know the basic weak acid formula.
This problem is interesting. Instead of giving Ka, it provides a Kb, which is, the first part is not titration yet. It merely asks for the pH of the buffer solution. This problem is interesting because it provides the Kb instead of the Ka. First of all, first write the H plus concentration equation for a buffer solution, which is Ka times the concentration of weak acid over weak base. Now we have Kb and we want to solve Ka, so in order to find Ka, we have to use the Kw equals Ka times Kb. Ka times Kb. Now we know that Kw is equal to 1.0 times 10 to the negative 14. And we want to solve for Ka, and we know what Kb is. Kb is 1.8 times 10 to the negative 5. Now to find Ka, all we have to do is plug into the calculator, and we divide 1.0 times 10 to the negative 4 divided by 1.8 times 10 to the negative 5, and we get the Ka of 5.56 times 10 to the negative 10. Like so. But since sig figs are important, we only see 2 sig figs in each one, so we say that Ka is 5.6 times 10 to the negative 10. Now that we have Ka, we can solve for H plus. And solve for H plus. To find the H plus, we have to first plug in all the values into this equation. So we know our Ka, which is 5.6 times 10 to the negative 10, and our concentration of weak acid over weak base. Okay, so we know that NH4Cl is going to be the acid. We need to figure out which one's the acid and which one's the base. We know that since NH4Cl has a Cl, that's going to be the acid, and NH3 is going to be the base because that's ammonia. So we put the concentration of the acid on top and the concentration of the base on the bottom, which is 0.25, like so. And now we just plug into the calculator, plug in chug, and we get a pH, or we get the H plus concentration of 8.9 times 10 to the negative 10. Now that we know the H plus concentration, we have to plug it into the pH equation, which is negative log times to the base 10 of the H plus. And our H plus is, so if we plug in our H plus, we get negative log 10 of 8.9 times 10 to the negative 10. And if we plug into the calculator, we get that the pH is 9.1. And this is all part A, which asks for the pH of the solution. This is part B of the problem. This one asks what is the pH after adding 0.1 mole of HCl. So from part A, we know that Ka is equal to 5.6 times 10 to the negative 10, and we know the buffer solution equation is H plus equals Ka times weak acid over weak base. The difference is you're adding 0.1 mole of HCl, so you cannot use the concentration in the equation. Instead, you have to use moles. Moles of this solution there. So instead of the big molarity, you have to use moles, big M. Instead, you have to use mole. Now, first of all, let's write what we know. We know H plus is equal to Ka, which is found in part A, which is, or times over weak acid over weak base. So, we know from the part A that we solved earlier that Ka is equal to 5.6 times 10 to the negative 10 times the acid over base. Now we want to find how much of each we have. So we find for the acid we have 0.40 molarity times 1 liter, which is given in the problem, so times 1 liter, the amount of it, which is equal to 0.40 moles of acid present. And for the base, we have a 0.25 molar solution, and we have 1 liter of that as well. So we have 0.25 moles of base. Now we add those into the equation. We have 0.40 moles of acid over 0.25 moles of base. Now you're adding 0.1 moles of HCl. HCl is an acid, therefore we're increasing the concentration of the acid present. So we add it to the top of the equation, the acid portion of it. So we add 0.10. Now what we do to the acid, we must do the opposite to the base. Since we're adding 0.1 moles of acid, we must take away 0.1 moles from the base. So we get this here. This is very important to reciprocate because the acid and base make salt. And once we plug it into the calculator, we get the H plus concentration, which is equal to 1.9 times 10 to the negative 10. Or negative 5, sorry. Now, once again, we have the H plus, so we plug it into the pH equation, which is negative log 10 of H plus. So we know that H plus is 1.9 times 10 to the negative 5. And we plug and chug into the calculator, and we get a pH of 8.7, which makes sense because the initial pH of the buffer solution is 9.1, and after the addition of the salt, or not salt, acid, we get a lower pH.
A review of what we learned. These are important, easy ways to get more points on any buffer questions. This equation will simplify any buffer problem and make buffers fun and easy. Remember to find the Ka value by using the Kw value, and make sure that when you find changes in the pH, you must use moles, not molarity. This is a must. Remember that when you add a base, you must subtract from the acid, and if you add an acid, you must subtract from the base. Now you are ready to conquer the land of buffers. Thank you for watching our video, and good luck, future chemists.